For this problem, we want to find exact value of the following sum. So the sum is having terms like 1 over 1 square root of 2 plus 2 square root of 1 plus 1 over 2 square root of 3 plus 3 square root of 2. And this goes on until we reach the last term, which is 1 over 99 square root of 100 plus 100 square root of 99. To solve such a problem, we try to come up with a generalized term, a term that represents all these terms of the summation. So if we look at the summation terms, we realize that the term of this summation can be written as 1 over n a square root of n plus 1 plus n plus 1 a square root of n. And we call this generalized term as Tn. Now, we try to work with this Tn and try to simplify this Tn term so we can come up with the summation. I can write this Tn as 1 over a square root of n squared. I replace n with the square root of n squared times square root of n plus 1. Nothing has been changed. Plus the square root of n plus 1 squared times the square root of n. And we can factor in the denominator from terms like a square root of n, a square root of n plus 1. And if we do that, from the first term we get a square root of n, and from the second term we get a square root of n plus 1. We now multiply both numerator and denominator of this Tn by a square root of n plus 1 minus a square root of n. So here we get Tn equal to a square root of n plus 1 minus a square root of n divided by a square root of n, a square root of n plus 1 times a square root of n plus a square root of n plus 1 times a square root of n plus 1 minus a square root of n. And this would be like in the denominator, like a squared minus b squared. So we get a square root of n plus 1 minus a square root of n divided, and the result of this would be 1 because we get n plus 1 by multiplying these two terms and minus n by multiplying these two other terms. So we get n and n cancel and we get 1. So this would be now divided by square root of n plus 1. And finally, we can write this as two summation terms. So one summation term would be a square root of n plus 1 over the denominator, minus the other one would be a square root of n over the denominator. Simplifying this, we get 1 over a square root of n plus 1, and n plus 1 for the first term will cancel. And for the second term, a square root of n would be cancelled. So a general term of this summation would be 1 over a square root of n minus 1 over a square root of n plus 1. So let's evaluate some terms of this as an example. For n equal to 1, we have 1 over a square root of 1 minus 1 over a square root of 2. For n equal to 2, we have 1 over a square root of 2 minus 1 over a square root of 3. For n equal to 3, we have 1 over a square root of 3 minus 1 over a square root of 4. And for the last term, for n equal to 99, we get 1 over a square root of 99 minus 1 over a square root of 100. So in this new format, we see that many of these terms would cancel. 1 over a square root of 2 with 1 over a square root of 2, 1 over a square root of 3 with 1 over a square root of 3, and likewise the summation would have only two terms. If I call this S as the summation would have then the first term, which stays, and the last term. So we have 1 over a square root of 1 minus 1 over a square root of 100. And S would be 1 minus 1 over 10 and would be 0.9. So this summation here would simplifies to 0.9 as the final answer.